All right, we are at the top of the hour. Welcome everyone to this NETGEAR AV webinar in Europe, 4 p.m. Central Time, 3 p.m. UK. We want to get it done in less than half an hour. I'm Laurent Masia. I'm the product management person for all the managed switches in NETGEAR. I'm responsible for the ProAV segment of our switching line. I'm also the director of the ProAV design team. So today, it's a very special occasion for us because, as you may know, we got a very successful ISE show 4 weeks ago in Barcelona, and we run a demo at the top of every hour, so almost 100 of times throughout the show, and we wanted to repeat that with some more guidelines and directions and best practices for you today. So how to design and configure an AV over IP network, this is what we want to do in less than half hour. Before we start, and I only have 10 seconds left for this introduction, please use the chat and the QA buttons if you want to ask any question during the webinar. We have Eric Hubert, he's our marketing EMEA manager organizing this webinar. We have two proud ProAV design system engineers. Also, Neil Smart in the UK, Laurent Masia in Ireland. They will take care of all your comments, remarks, and the questions in the QA box during the webinar, and they will take maybe the most relevant for everyone at the end of the half hour so that we can have a live QA session. So I think I completed the duties. Let's go without further ado. We want to demo how to configure and a network for AV over IP using the NETGEAR AV line switchers. But it's better to start with a quick intro so that we can set the stage and understand where we are going. Okay, so what is AV over IP? Well, before we got analog and digital, and then we got HDBaseT point-to-point circuit-based distribution. But HDBaseT did not use any network cabling, right? It was using cables for sure, but not Ethernet switches. So with AV over IP by now, this is good because you can use the standard IP network with a network switch as a switching fabric so that all your AV sources, as you can see on that screen on the left, you have those encoders that we call transmitters, TXs. They will take your audio or video sources, and then it will packetize your AV. It goes through the network, and on the other side, your packets get to those decoders, so receivers or RXs, and your AV can be back on your displays or your speakers. So this is so much more flexible because now all the features that you need, like the routing, the scaling, this is all based on software, not hardware. And of course, it's way easier for expansion because by nature, Ethernet is expandable. But look at the center. The switching fabric now is a network, right? So you see that switch. It needs to be good for sure, because if not, if you have tons of AV network equipment around, doesn't really matter. The whole AV experience really can be ruined. So we at NETGEAR, we partnered with the first video over IP manufacturers almost 10 years ago, and we helped found the SDVE Alliance, for those who remember, with Sony, Christie, ZV, Semtech, Aptovision for sure. But since then, NETGEAR has become a proud member of the largest AV alliances in the world to help standardize and facilitate the transition to AV over IP. So, we looked around and we said, unlike some enterprise IT vendors, and we will not tell any other competitive names during that presentation, but some enterprise vendors always pointed the finger to the AV devices, so saying, well, you don't respect the IEEE standards, or switches do. So we at NETGEAR wants to be different. We wanted from day one to help that transition by simplifying it, standardizing it, but from an AV standpoint, really not from a IT standpoint. So now this is the result. One by one, in less than 10 years, NETGEAR went to more than 200 AV manufacturers, and we offered our help for a mutual certification process. So what does it mean? Well, it means that we offered to test the AV equipment in the NETGEAR labs across the world. And we also sent all the time our switches for testing at all these manufacturers in order to find, the most robust interoperability, and of course, eliminating any possible issue. So the result is that, well, the configuration, the setup was drastically reduced, and those AV manufacturers were happy because they could standardize on a AV switch platform. But of course, it then reduced the tech support load and hassle, right, for them. But now I'm pretty sure you will find your favorite AV manufacturer in that list. If you do find it, it means that we have a configuration for it. Now, well, I think you can understand that the results were hundreds and hundreds and hundreds of different configuration files and white papers and case studies and application notes. So needless to say, we understood that all the pressure still was on the AV integrators, on you. And misconfiguration, as you may know, even on a certified switch platform, this is an AV over IP worst enemy. So if I could see you, if you had your cameras on, I think some of you might smile right now because you've been there, right? So 3 years ago, we decided to start from scratch again. And with the help of all these manufacturers, we assembled all the certified configurations in AV profiles, in a easy to use AV user interface, so that it is eliminating for you the need for all the traditional, cumbersome IT settings. So that's what I want to show to you today. But now, well, as I think you know where I'm going, right? Because the hardware seems to be good, the software looks to be good, but that was not enough. Because which switch should you select? How do you interconnect switches across multiple rooms? And also your Dante controller maybe cannot see those AES67 IOs, right? Or what can you do if your QC score is not the grandmaster for PTP? And your control, so many things can go wrong. And this is during a project and of course after a project. So for you AV professionals, NETGEAR formed a team of certified AV/IT system engineers who can help you across the world and the time zones at no charge. And you are just one email away, proavdesign@netgear.com, proavdesign@netgear.com. All right. So now, if you look at the service and the support from that ProAV design team, you have two members today on that call, that webinar, Laurent from Ireland and Neil from the UK. You can understand why NETGEAR, the AV line today, by far, is the most recommended switch in the world for AV over IP. And this is true, actually, whether in ProAV, professional AV, but also residential AV, medical AV, and even broadcast and lighting markets. So we, at NETGEAR, we are committed to the transition to AV over IP, and well, we can support you for any project, believe me, big or small, right? So today, we don't want to talk about the switches much. I just want you, because now you can understand that, why for AV, a switch is not a switch. So there's way more to it. And despite the fact that we at NETGEAR have hundreds and hundreds of different switches, this because any glitch can be catastrophic in an AV over IP installation. When you will come to us and start your AV journey with the ProAV design team, those are the AV switches, the 4250s, the 43s, the 4500s. These are the ones that we will use because they are approved by the ProAV vendors, they are certified. So from the desktop up there, the desktop switches that are good for conference rooms or mobile studios, to the elegant 4250 with the rear-facing ports, elegant models when they are in your AV racks, and down to the most robust and redundant switches, the 43 and the 4500s that are certified up to thousands, literally thousands and thousands of AV endpoints. And please note that the common denominator is the non-flooding multicast. That's what makes the most difference. The multicast is not flooding between those switches. because NETGEAR fixed the IGMP standard for you. All right. So today we are going to demo the EV user interface and the Engage controller. All right. So I know Eric is monitoring this. I think I'm on schedule. This is the lab we are going to use together today. All right. So Laurent's PC is my PC. I'm talking to you right now using my corporate gateway. So this is a 192.168.10.24 subnet, okay? But I also have, from that built-in NIC, access to the out-of-band management of all these switches in the lab. So every switch gets an IP address from the OOB side of things, from the gateway. And yes, those switches from their main VLAN, the VLAN 1, they get an IP address from another gateway so that we can manipulate the AV profiles together and do some exercise, maybe clarify some things between the VLANs, how we can do the inter-VLAN routing. All right. So, of course, we could connect to the switches one by one, but what we were demonstrating at ISE in Barcelona was that new NETGEAR Engage controller. So this network over here is already in the NETGEAR Engage controller. What's that? Well, that's an application. It runs on Windows or Mac OS. You can download it from netgear.com/engage-download. And you don't really need to install it. That's a big zip file. You can uncompress that file onto a thumb drive if you want and run it from Windows or Mac. So this Engage controller has discovered all the switches in the lab. As you can see, this is the out-of-band 192.168.10.24 subnet, all right? Why is that? Because when I created my lab, my site in the controller, in the setup of that site, I chose to use a dynamic IP address scheme. So my controller is using a DHCP client NIC on my computer that you can see here. And the controller is expecting that all switches are DHCP client. Of course, if you do not have a DHCP server when you install your site, you will then maybe use a static IP address on your controller, or better, maybe a static IP address plus a DHCP server, so that temporarily your Engage controller can act as a DHCP server so that you can attribute DHCP addresses to your switches. All right, but in this case today, this is all DHCP, and frankly, this is the best advice I can give to you. It's always better initially to use a DHCP server so that your switches get an IP address, OOB or VLAN 1. All right, so what do we want to do? Okay, if you agree, we are going to repeat. We want to do first a Dante primary VLAN, okay? We want to have Dante primary across all these switches. And because we have a little bit more time, we are going to do a second profile for video. And why not using a NVX video profile, okay? So to do that, instead of doing this on switch after switch one by one, we will go to our site settings, and we are going to find out that the default VLAN 1 is already there, because the switches, they ship with a default VLAN 1, and all the switches, all their ports belong to the VLAN 1, all right? But, well, we are not going to touch it, because this VLAN 1, let's say that we want to use it for control. This is where we will have our controllers or controllers to just monitor the entire AV installation. So let's first create a new profile. We said that we want to do audio Dante, and we are going to give it a name. Maybe this is going to be our Dante primary. You will assign a VLAN ID. That's going to be the VLAN 20. And because we are optimistic always at NETGEAR AV, we are going to use the green color, all right? Next is the port assignment. And what you see right now is new, because this is the future version of our Engage controller. Today with Engage, you stop there and you go back to your device list and do the port assignment manually, switch by switch. But in a few weeks from now, this Engage 1.1 will be out. You will do that this way. So now it's time to tell the controller which ports are going to be used on every switch. So we are starting with the left, the 4300 GSM 4328S. And to keep it simple, I'm going to use the first 4 ports on every switch, all right? So the 4328S is done. This is the core switch, and I'm not going to tell you why right now, but because I do not connect any specific Dante device at my core, I don't need to assign ports to the Dante. All the NETGEAR magic, auto trunk, auto lag will take care of the aggregation at the core. So let's go back to the access with the first 4250 switch. We are selecting the 1, 2, 3, 4. You can see, and you can review, I mean, real time. If you are doing any mistakes, you can control what you are doing. And let's populate the entire network with the green ports for Dante, okay? So the 4300 fiber switch, I have another switch just here. Oh, actually, I need to reduce that a little bit. All right. So let's go to this one. And now we have a ultra PoE switch that we just did. All right. So now, as you can see, all the switches are green because we configured them all. And we can quickly review, and we didn't make any mistake. We have the 4 first ports of every switch assigned to the Dante VLAN 20 using the Audio Dante AV template. All right. So now we can say apply, and yes, we confirm that. So mission accomplished for the Dante. Let's create now a video profile. Let's say in this case, we want to use some Crestron digital NVX. So let's use the video profile. This time it's going to be my NVX video, and the VLAN ID will be the 40. And let's differentiate this time with some yellowish color. All right. And well, let's redo the port assignment. Let's start with the first switch. And maybe for this example today, let's say we want to use 4 ports, starting port 17 on all the switches. All right. So 17, 18, 19, 20. We are going to do that across our network. This is the access. This is where you will actually connect all the NVXs, okay? 17, I said, 17, 18, 19, 20. And the last one, a desktop 4250 switch. We said 1, 2, 3, 4 for the first Dante. Let's say 5, 6, 7, 8, all right? You can have a quick check. It's all symmetric. We're good. We click apply. And now, well, I'm happy to tell you that your network is ready to receive all your Dante equipment on the first 4 ports on every switch and all your NVX equipment on the last 4 ports on the right-hand side for NVX, all right? But now you may want to have a DHCP server. You may want to have your Dante devices receive a DHCP address on the VLAN 20. All right, because this way they won't use the 169.254, link local IP scheme, and that's better because if you want to do control from the VLAN 1, the 169.254 is not routable. Same thing for the video. So to do that, let's go back to the topology. We want to do the layer 3 configuration, the DHCP server at the center of the network. So the core, we are going to use the core fiber XSM 4216F switch. All right. So to do that, we can configure it from here. For instance, let's fire up the AV user interface for the core switch. As I told you, all the ports, they show the A, which means auto trunk, or the lag, the L1, the lag number 1, or the L2, the lag number 2, because it's all plug and play on those AV line switches for you, so you don't have to worry. All the interconnect, the lagging, the trunking, everything is ready. But of course, we could assign some green ports or yellow ports if we would connect some devices directly, but everything else is in trunk mode automatically for you. All right. So let's go to the network profile, hiding the legends. The VLAN 1 is already a DHCP client. It got the first IP address from the DHCP server on that network. It's 10.0.0.1. Let's configure the green Dante. So this is provisioned. We don't assign any ports, but at the core, you want to toggle the edit button so that you can assign a static IP address to the VLAN 20, your Dante VLAN at the core. And let's say we want to do a 192.168.20.1. It's going to be symmetric this way with your VLAN 1. And yes, you want to fire up a DHCP server. And I don't know how many of you did try to do DHCP server on managed switches before, but usually it's really complicated in the IT interface or the CLI, right? So here we made it simple because you should focus on your AV, not much on the Ethernet backend. So this is our main VLAN 20 interface, the 21, and we are going to start at 100 and finish at 200 so that you have plenty of free IP addresses for your statics, okay? And that's it. All right. No DNS servers are configured, so that's a problem for internet, but I don't know for you, we don't plan to do any internet with the Dante devices anyway. All right. So when I click apply, all the configuration for the DHCP server is sent to the core switch, and now it's done. Let's do that on the yellow NVX VLAN 40, and let's redo the VLAN warning edition. You say static, this time 168.40.1 should be our interface on that switch. And let's also give some room for the statics. Let's start at 100 and go up to the 200, okay? So please understand what we are doing here is only at the core, because no DNS, no internet, we know that. On the other switches, the VLAN 20 and the VLAN 40, they can stay at the layer 2 because all the routing, the DHCP server addresses will come from the core, all right? So we can go back to the topology. Now we have a DHCP server for your Dante and for your NVXs at the core. If I go to the site neighbors, if I filter and go to my 42UX switch, I will find a video device over here. But see, it's connected, but it's still the old IP address. We just, moved that port 5 minutes ago to the VLAN 40, but before it was VLAN 1, so that device will not get an IP address. We should reboot the devices, right? So that they get an IP address from the DHCP server. So let's go to that switch. We click configure. As I told you, on that switch, we do have some green ports. We do have some yellow ports. The VLAN for Dante and video, still layer 2 because we know everything is done at the core. But let's go to the Power over Ethernet. And we see that device over here. We could actually have checked that before going to the overview. You see that device, the IP address seems wrong. It's still an old VLAN 1 IP address. So to reboot the port 17, you select it in the Power over Ethernet section. You click reset. And now the video device is rebooted. And now we need to wait until it's coming up with the new IP address. And the fact and the matter is that the way the NETGEAR switch is getting the new IP address, it's using LLDP. So in the neighbor table, we are going to see it after 30 seconds because the LLDP packets come every 30 seconds. But so that you understand, this camera, because it's a camera actually, is on the port 17 of that GSM 4248X switch right there. So I think the 30 seconds are almost past. Let's see. Now this device got the 192.168.40.100. So the DHCP server in the video NVX VLAN is working. So now, well, we have 6 minutes left. So Eric, I know you're monitoring. I'm doing my best to keep it in time. But now let's say that you want to control that video device, which is in the VLAN 40. You can get to the neighbor page and you can observe that this device is in the VLAN 40, but you want to control it from the VLAN 1 because this is where the VLAN 1 you have all your controller equipment. So let's see, do you think we can ping that device 192.168.40.100 from the switch to start with? So to do that, you go to the diagnostics, to the troubleshooting, and let's just ping that device, 192.168.40.100, and use the ping. It should work. Why? Because in this AV user interface, we don't even specify which interface we are using. So if an interface from the VLAN 40 is used, of course, it's going to work. Well, actually, it did not work. 4 packets transmitted, 0 packet received. Okay, so to do this, we need to verify again that we are not wrong. We have the device connected, and the device is 192.168.40.100, right? So let's start again. Let's use the troubleshoot, 192.168.40.100. Let's ask the switch. Oh, I know. We are on the edge switch. We are on that switch, okay? And there's no IP interface on the VLAN 40 because we stayed layer 2. So you should actually instead consider the core switch in the topology. This is where you have your IP interface, the core switch. So, pardon me. This is called the demo effect, okay? When we demo, there's always something wrong, but hopefully we found the solution. So on the core switch, we do have an interface on the VLAN 40, so definitely we should ping the 40.100, right? So diagnostics, troubleshooting, 192.168.40.100. Let's ping this camera. And from the core switch, it will work. As you can see, the core switch can ping, but again, we can ping because we probably use the VLAN 40 interface. So now what we can do is to control from the other VLANs, because you cannot do it on the EVUI or the Engage controller. You can launch the IT GUI of that switch. And this, let me tell you that you should not do anything in there. Please never try to do things in the IT GUI because you can only conflict with the Engage controller. But for troubleshooting, you can open the IT GUI of that core switch. In the switching VLAN, you have your VLANs and all that. You go to the maintenance, troubleshooting, and now we can try to ping 192.168.40.100, but I will try to ping it using the VLAN 1 interface. Remember the 10.0.0.1 interface, the VLAN 1. Click apply, and in not much time, we should see that this is working. Yeah, this is working. So because you have the inter-VLAN routing in the switch, you can do it. But now I am on that VLAN 1, okay? I am on this VLAN 1 over here. I am on the 10.0.0 VLAN because I have a second NIC. So the question is, can I do it? So let me show you. My second NIC is in the 10.0.0 VLAN 1 as well, all right? But can I ping this device? Well, going to my IP config, I see that I have 10.0.0.249, but if I ping that device, 192.168.40.100, using as a source my 10.0.0.249 NIC, well, unfortunately, I cannot ping it. So maybe someone is fast enough to tell me in the chat, why is that? But as you can see, this is timing out. So if you have a controller in that situation, same thing, this controller cannot ping your device into the VLAN 40. To understand why, you need to redo the IP config and see that I'm using the 192, I'm using the 10.0.0.254 gateway. So the 254 gateway is another gateway. And this gateway over here doesn't know anything about the VLAN 40, where the camera is. So one way of fixing it is to just change the gateway of my computer, all right? So double-clicking on my USB NIC, if I alter the configuration this time, so far I was using 10.0.0.249, so that's not a class A, right? This is a class C. Let's configure this right. But instead of using, instead of using the main gateway, if I use one of the switches VLAN 1 interface, so for instance, I know that the core switch is 10.0.0.1, now I should be able to ping this device. Let's try, okay? Yeah. I'm probably funny. The SEs in the call must smile because they must say, hey, Laurent is tired. All right. So now we have our gateway configured. Let's see, 10.0.0.249. As before, it's a static with 10.0.0.9. Let's try to ping our device. Woohoo! It's working. Okay, so now, despite the fact I am on the 10.0.0.249, I can access the device because I use a switch IP interface as a gateway. This is how you ensure 100% success when you want to traverse the VLANs for control unicast only, manipulating devices from the control VLAN to the other VLANs. So we are at the bottom of the hour. I understand that some of you might leave, but I have a last example to give to you. So if you have some time, you can actually stay with me for 5 more minutes. If not, I can actually tell you that if there's one thing you want to take out of this webinar today, is the ProAV Design email address, proavdesign@netgear.com. ProAVdesign@netgear.com. This is a full team around the world, but we have a lot of personnel in Europe that can help you before, during, and after any project, from the design to the configuration to the troubleshooting. And we would be very happy to accompany you for any of your AV over IP projects, ProAVdesign@netgear.com. But now, let's say that we want to go back to my example, because you cannot configure your controller to use the VLAN 1 IP interface as a gateway. You really get to use the corporate internet network gateway. So how can you do that? Well, if you are fast enough, you can use the chat box and try to guide me, but I will undo what we have done over here. I will go back to a DHCP, okay, a DHCP. So I will again catch an IP address from the gateway. Let's give my computer some time. If I click details again, as you can see, I'm using the 10.0.0.254, all right? So now my ping doesn't work anymore because that's what we were using 3 minutes ago. So how do you do? Well, it's very simple. You need to configure the routes on your main router so that this main router is aware of the VLAN 20 and 40 subnets. So how do we do this? Well, we just need to connect to that router. So today I'm using a pfSense. We are going to go to the system, going to the routing, not register. And first thing you want to do is to configure a gateway, a downstream gateway, to tell your pfSense that you have a gateway that is 10.0.0.1 in the main subnet. So to do that, you just add a gateway. This is on the LAN side of things, right? So you select LAN for interface. You said that's your XSM 4216F core gateway. And this gateway on the main subnet is 10.0.0.1. That's all you need to do. All right. You click Save. And of course, you want to apply. So now you have your gateway ready. You can then go back to your static routes and implement the routing. So the first destination you want to do is for your Dante. We said it's 192.168.20 subnet, right? And let's not go crazy with the mask. Let's use the 24. And the gateway is the core. This is the gateway you have created. So now the main gateway knows how to reach the 192.168.20.024 via this gateway. And second, before we apply, we want to add the 192.168.40.0 subnet. This is your VLAN 40. This is a 24 subnet using the same gateway. Save. All right, click Apply. We are going to review quickly. We are using now a route to go to the 192.168.20 and 40 subnets. And for that, we configured the gateway that is 10.0.0.1. And to me, it looks correct because this is how the main core switch goes to that network using the 10.0.0.1 DHCP interface. So now I can tell you that my expectation is that despite, and there's no cheating on this call. See, I'm using the 10.0.0.249 with the gateway that is outside of the switch, right? Still, but if I ping my camera, the 4100, using my NIC, the 0249, it's working. So now the network knows how to route any control equipment that is in the VLAN 1 from the main gateway. So you got to do this maybe in some instances when you cannot use the switch IP interface as a gateway on your control devices. And because we are at it, and I told you we try to use what we preach, we should try to fire up this device, don't you think? Hey, you have access, it's working. So now you should be able to see a small camera just capturing the lab actually that we are using right now. All right, so let me recap because that was a dense webinar. But what we've done today is that we configured a network together capable of doing Dante and NVXs across a number of switches that is for that available in the NETGEAR Engage controller. You, with me, created a profile for Dante primary, VLAN 20 and 40. Now everything is layer 3, everything is routable. You can connect any device in the VLAN 1 to control your equipment in the Dante and the NVX. And it took us less than half an hour. So thank you, everyone, for your attention. I promise to you this webinar today is recorded, so that will be available on the NETGEAR partner portals very soon. And before the end of the week, I hope on YouTube. So thank you for your attention. It was a great joy for us to see you at ISE and to see you for that recap today. As I told you, one thing to take away today, if there's one thing you want to remember, go to the NETGEAR ProAV design team for any of your AV over IP projects. You are one email away. ProAVdesign@netgear.com, ProAVdesign@netgear.com. Thank you.